State the value of f of x when x is equal to 5. So in the first example, they have given you an x value and they want you to find the y value. Because remember that when they write f of x, this really means the same thing as y. So if they have given you the x value, then you can look it up on the graph. You don't have an equation to plug it into, but you can look it up. So we're going to go to x equals 5, which is right here. And we're going to read the graph, go up like this, and then you're going to read and see what this point is. So if you read all the way to the y-axis, you'll see that the coordinates of this point are 5, comma 1. So you would say that f of 5 is equal to 1. The technical answer, if this was numerical response to put in the box, was you would just put 1 as your answer. Okay. In part B, it actually gives you something else. So this is a different question because they have given you f of x equals 5, which means they've given you y is equal to 5, and they want you to find x. So if you go in there, you're actually looking up what is x when y is equal to 5. So we're going to go up to y is equal to 5, and we're going to read all the way to the graph, and then we're going to read down to the bottom, and we're going to realize that, oh, the value of x is 7. So x is equal to 7 when y is equal to 5. So this is your answer right here. Here's question number 2. It says state the value of f of x when x is equal to 4. So that means they want you to give them the value of y, and they have given you the value of x. So we're just going to look up x is equal to 4 on the graph right here. And it looks like our y value at that point is negative 1. But because we are using function notation, we would say that f of 4 is equal to negative 1. And if this was just a short response, you would just put that your answer is negative 1. State the values of x when f of x is equal to 1. So in this case, they have given you y and they want you to find x. So we are going to look up y is equal to 1 right here. So there's us on the y-axis. The interesting thing is that if you look up y is equal to 1, it hits two different values of x. It hits 1 at negative 1, and it hits 1 at 2. So actually, there are two x values, and you have to put them both. Otherwise, you're wrong. There's 1 at negative 1, and there's 1 at 2. Interesting. So a more interesting question is, because of this, does this make this graph not a function? Actually, it's still a function because you're allowed to have two values of x for a value of y. What you're not allowed is if you look up a value of x and you hit two values of y, that's not a function. So this, for all our purposes, still passes the vertical line test. So it is still a function. So a student just pointed out that I missed one, because if you're looking at 1 down here, there's actually another value of x that it hits right there, which is at the number 5. So actually there are 3 values of x that get hit. So when they give you a y value, what you have to do is you have to actually draw a line right at that y value, and you have to record all the values of x that get hit by that y value. So just be careful of that. I actually missed the third one, and a student caught it. So there are 3. So making statements about points A and B in function notation, what are they really getting at here? If you see this in the book, what they're just asking for is for you to write these points. So there's a point here at negative 6 and negative 3. So for A, you really just want to write that f of negative 6 is negative 3. They want to see that you understand that the x value goes here and the y value goes there. So for B, we have a point at 3, 0. So you would just write that f of 3 is equal to 0. It's just function notation. That's what they're looking for. So in this example, number 4, they have defined a function not as an equation, not as a graph, but as a set of ordered pairs. A tip for you guys whenever you see something like this is that if you write the ordered pairs one on top of the other, it's going to make things a little bit easier for you to see. So for example, I'm just going to rewrite this out, 16 comma 7, and then on top of that, I'm going to write this like this. And I'm just going to stack the points. And the reason I do this is because then it's easier for you to see which are the x values, which are over here, and which are the y values, which are here. And that's going to help you out a lot. So the first question asks, what is f of negative 1? The important thing to understand here is they have given you x, and they are asking for what is y. No. Okay, so they are asking for what is y in this case. So when we go to our list of points, we are looking up where x is equal to negative 1. I do not care about the y equaling negative 1 right here. When x is equal to negative 1, then y is equal to 16. But if they want us to write this as function notation, you would say that f of negative 1 is 16 instead of y is 16. Okay? So that's where writing this in columns really helps because it tells you that you can ignore this negative 1. It's a y value, and you were looking up an x value. In part B, it says, what is the value of x, or values of x, when f of x is equal to 16? So again, you really have to be clear here. Have they given us x or y? They have given us a y value. And you know that because there's no number here in for x. So they have told us that y is equal to 16, and they want to know what is x. So we're going to go back to our list, and we're going to look up where the y value is 16, here and here. And we're going to look up what is x in those particular cases. And we're actually getting two different values. So at those numbers, we are getting x is equal to negative 1 and also negative 3. So one final note is that this still counts as a function, because if you look at the x values, there are no duplicates. It is totally okay for it to have y values that are duplicated. But if I had another point, for example, that said like negative 1, negative 3, and that was part of the function, I would say this is no longer a function because the x values are duplicated. So just keep that in mind. It'll be helpful. State the value of f of x when x is equal to 0. So we're going to go here and we're going to look up x equals 0. So we're going to look that up and we're going to go up here and find the value of y at that number. And it is 3. So 3 would be the answer, but if you wanted to write it fancy, you would say that f of 0 is equal to 3. There's only one value. State the values of x when f of x is equal to 2. So remember, they have given us a y value. They want the x values. So if I want to be really technical about this, I could draw a line right here where the y value is 2. And we could see all the x values that hit that line. So we could go back and see that there's 1 here at negative 4. There's 1 here at 1. And there's 1 here at 3. So you would say that x is equal to negative 4, 1, and 3. So point A, if you look up the coordinates are at negative 2 and 4. So you would say f of negative 2 is equal to 4. Do not mix up those numbers. You're going to get it wrong. And then for point B, we're looking at 2 comma 1. So f of 2 is equal to 1. What is f of 2? So they have given us an x value. We are going to look it up on our mapping diagram over here. And they want us to do the y value. So it happens to be 4. So you would say f of 2 is equal to 4. And if it was numerical response, you would just put 4. What is the value of x when f of x is equal to 4? So they have given us a y value. We need to look that up over here. So there's the y value that they looked up. And then we would track it backwards. And we would say that actually the answer to this is 2. X is equal to 2. I guess I should have asked a different question. So for example, if I had asked what's the value of x, so this is part C, if f of x is equal to 1, then you would have to look up 1 on the y list, and you'd have to go backwards, and you would say, oh, x was equal to 9 in that case. Okay, so we are given two functions, one called f of x and one called g of x. In part A, we only care about f of x. Doesn't even address g of x. So f of x is equal to negative 3. So they've given us a y value here. Y is equal to negative 3. So we're going to go ahead and plug that into our equation. Negative 3 for f of x is equal to 2x plus 5. Very important that you plug in for y and not x. So we're going to subtract 5 from both sides. Negative 8 is equal to 2x. Divide both sides by 2. And you're going to get a final answer of x is equal to negative 4. Done. In part B, it says, what is the simplified form of f of x plus g of x? Now, already I have a clue that this is not going to be a number because it did not ask for the value. It asked for the simplified form. So what this means is that our final answer will be an expression, and that's totally okay. They have not told us what to plug in, so I'm just going to take f of x, which was 2x plus 5, and I'm going to add g of x, which was 1 minus x squared. Now, normally I would do this in brackets, but because it's a plus, those brackets don't matter. If it was a minus, those brackets would matter a whole lot. And if I simplify this by combining like terms, I'm going to end up with negative x squared plus 2x plus 6. So you're literally just adding them because they didn't give you any numbers to put in. If they did give you numbers to put in, like if they wanted this and this, f of 1 and g of 1, you could plug it into them separately and then add them at the end. Or you could simplify your expression and plug it in at the end. But I think for most students, it makes more sense and you're less likely to make a mistake by processing this and then processing that and then adding them together at the end.